Example 6 says the weekly sales S of a product during an advertising campaign are given by S equals 100t over t squared plus 100, defined on the interval where t is greater than or equal to 0 and less than or equal to 20, where t is the number of weeks since the beginning of the campaign, and S is in thousands of dollars. Over what interval are sales increasing and decreasing? So in order to figure out part A, we need to take the derivative of the S function. So let's go ahead and do that. We are going to need to use the quotient rule since we are dealing with a rational function. So S prime is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And recall that, well, first of all, let's simplify the numerator. So we have S prime is equal to 100 t squared plus 10,000 minus 200 t squared over that same denominator. And I'm just going to put a star to indicate that, I'm too lazy to copy that thing down. So we have S prime is equal to, if I simplify the numerator further, we have negative 100 t squared plus 10,000 over t squared plus 100 squared. All right, so recall from a previous example, I said that when you have a rational function and you are wanting to solve for when it equals 0, a rational function is equal to 0 when the numerator is equal to 0. So let's go ahead and solve. We are going to set the numerator equal to 0. And if I subtract 10,000 on both sides, we get negative 100 t squared is equal to negative 10,000. And if I divide both sides by negative 100, we get t squared is equal to, the negatives will also cancel out, so we'll be left with 100. And then if we take the square root of both sides, we get t is equal to plus or minus the square root of 100, which is 10. Now, recall from our domain, t is only defined when, or excuse me, the function is only defined when t is greater than or equal to 0 and less than or equal to 20. So really, we only want the positive value, t is equal to 10. So that is our critical value. So let's erase this here. I'm going to make my sign chart, and I have positive 10 here, and I want to use my test numbers. So let's see, I'm going to use 0. So that's, an easier number to work with. And then let's say I'll choose 20 as my other test number. And so if I plug in 0 into my derivative function, let's see, so S prime of 0 is going to equal 10,000 over 100 squared, which is also 10,000. So that's going to equal 1, which is positive. And I also want to evaluate S prime of 20, and that's going to be negative 100 times 20 squared. So that's going to be negative 4,000. Excuse me, I meant to say negative 40,000, and then negative 40,000 plus 10,000 would be negative 30,000 over 20 squared is 400 plus 100 is 500. 500 squared is some positive number. So this is going to be negative here. So finally, to be able to answer part A, we would say S is increasing, or in order to be more specific, I should say sales are increasing on the interval 0 to 10, and sales are decreasing on the interval 10 to 20. So part B says, what are the maximum weekly sales? Well, we know from our sign chart that our function is increasing and then decreasing. So that means that there is a relative maximum when our t-value is 10. So let's go ahead and plug in 10 into our original function and see what we get. So 100 times 10 is 1,000, and then 10 squared is 100 plus 100 is 200, and that simplifies to 5. However, remember that S is in thousands of dollars, so that means that max sales are $5,000 after 10 weeks since the beginning of the campaign. Okay, and then part C says sketch the graph for 0 to 20. So this is going to be a really rough sketch. So we know here at 10, the output is $5,000. So this is our S-axis and this is our T-axis, and it only happens between 0 and 20. And so we know that this is a relative maximum here. And so if you evaluate S of 0, and I'll let you verify this, so go ahead and do this on your own to verify, but S of 0 is equal to 0, and S of 20 is equal to 4. So if I plot those points there, let's say 4 is right there. So if I graph that, it's going to look something like that. And that completes example 6.